Now, the these different types of propagation model, what all are the major differences between the two? The major differences are the location of these models. So some of them were basically tuned in Tokyo, another one was tuned in Dubai, somewhere else. Then it also depends on the frequency range, and it also depends upon the clutter type that we are using. So which clutter type that you are using, it is also impacting that as well. All right. So now when you know about the cellular propagation model, next thing for us to know is what and how these propagation models could be tuned, which is known as propagation model tuning. Now, what is the purpose of model tuning? You may already tell me that there are predefined values in atoll and asset and in planet which I can use, right? So why do I need to tune a propagation model, right? Because these propagation models which are defined in asset or atoll or planet are very, very generic in nature. That means they will not consider the factor that there could be there is, let's say, a bridge, right? So you will see it will consider the height of the mobile station at this point of time, but the actual height of the mobile station is this much, right? Because there was a bridge, and that bridge is not in the consideration of this model, right? Then the physical environment vary from location to location, right? The model which was tuned for Tokyo will not work in Taiwan, and the model which was tuned in Taiwan will not work in Jaipur. The model which is working in Jaipur will not work in London, right? So the physical environment actually varies a lot, and which has a very vital role to play in model tuning. So generic models will not be able to give you the accurate results, right? So what we need to do, we need to take the CW measurements and tune them accordingly. What is the meaning of CW test? CW test is nothing but a drive test which will give you a scanner type information. It will have its lat, it will have its long, and it will have the signal strength. So this is the major things which you get it in a CW test. CW, where the CW stands for continuous wave testing. I'll tell you a very interesting stories. Around tens of years of back, when I used to work in Aircom Tioco as a planning support engineer, we got a call from one of our customers in Nepal, and they were telling us that in spite of using a CW test, can we use our temps drive test files and perform a propagation model tuning with that? And we said, yes, it is possible as long as you give us, as long as you fill the tool with this information, probably it should work fine. They did the model calibration, and when the result come out, it was a 3-sector site. It became like a rainbow, and from the one site itself, the signals were initially good, then they become average, then they become bad, then they become poor, and then they become bad, then they become poor, then they become average, then they become good again. So you won't believe, using only one site, the entire network was getting covered, and that too in a hilly region like Nepal. So the tool was giving, so they come back to us and then they said the tool is not working, this tool is giving us garbage output. it become a big fuzz. When we did the troubleshooting, root cause analysis, we identified that if this is the site and you have a drive files like this, so signal strength was initially 60, become 70, then become 80, 90, and then become 80 again, then become 70 again. So when you are moving away from the site, signal initially goes down and then become bad and then become good and then become bad. This is what was happening there. So what does that mean? It simply means because they were using the temps drive files, and in the drive files there were handovers which were taking place from one point to another point, and because of the handovers the signal strength was actually becoming good after some distance of the site. Okay, so what we did is we asked them, it was a GSM, so we asked them to lock a particular frequency and the cell where they were connected with, and then perform the drive. Okay, so when they did that, everything become fine, no problem. So I hope it gives you a little insight of how the things are working. But CW test is very simple. It's a scanner test. In the CW testing, we use a radio receiver. Yes. So the purpose of CW drive testing, you got it, that before a network is actually launched, you can put a test BTS. Usually this test BTS is high power test BTS. On an average, you can increase up to 63 dBm of power also can be transmitted from here. Then you perform so high power BTS, and then you have a scanner which is also high sensitive scanner. High sensitive scanner, so it can cover a larger distance and a better area could be calibrated. So the idea is very simple, right? If your power transmitted minus power received. So if your power transmitted larger, power received is larger, it doesn't matter. The path loss is going to remain the same. As long as you are in the same frequency, same distance between the base station and the site, it doesn't matter whether you're using high power or a low power or high sensitivity, low sensitivity, because the purpose of model tuning is to identify how much path loss is happening, right? So we need to take CW drive test equipments, which is a radio, which is a vehicle, right? A GPS receiver, a disk storage, a gyro information. Usually now GPS itself becomes smarter, so no gyro information is required. Then you have radio receivers, right, to receive the signals, to transmit the signals. Now we need to understand the practicalities of the CW test. Practicality, you need to consider only two things. One is that you should do the drive testing in the radial paths as well as the circumferential paths, because the radial path will show you slow fading margin, right? When you move away from the site, distance, signal strength, this will help you to be calibrated using the radial paths. All right. Then circumferential routes will provide you fast fading margin, right? Or they will give you the prediction of signal strength in different directions from the base stations, right? So you're moving in this direction or you're moving in this direction. So how the signal strength is getting different. Okay. So once you collect the data, after that you may need to filter out important information only, right? For example, if you're doing the drive and there is a road which is blocked, so on this your signals are, you got too many signal stamp values which are not required, so you can filter them that I will consider the signal only after 5 meters, or usually 10 meters is the filtering distance which we consider. 10 meters, 5 meters. It is ideally the size of your map data. So if your map data is 5 meters, you need to consider this 5 meters. So that in 5 meter, if I have 10 samples, I will consider only one average or one filter out sample from those 10 values. And then next 10 meters, I'll consider only one value. So in this case, your CW file information will become smaller and it will become easier for the tool to calibrate the values in a better manner, right? So this is the filtering of distance. Similar way you can do the filtering of time, etc. Then perform the trial and error approach. There are automatic model tuning features are available, licenses are available in the planning tool. You can make use of them. Calibrate the values. The overall idea of doing the calibration process is that your mean error should be as small as 0 and your standard deviation should come in the range of 7 to 10, 11, something like this. So it should work fine. Between 7 to 10 of range, this is totally fine. So your model is calibrated without any issues. So this is what we have in chapter 3. And I will see you in the next chapter. Thank you so much.